In this video, we're going to take a look at a few examples that focus on what is and how to find the absolute rate of change. And you might be going, what is an absolute rate of change and how does it differ from an average rate of change or a slope, which are terms I probably saw in some of my previous math classes? Well, here's a little secret. It doesn't. It's the same thing. It's just another way to refer to it. But we add in that sort of absolute term because just in our previous lesson, we were finding absolute changes and absolute differences, and those are building into this absolute rate of change because it's an absolute increase or decrease, that change, but we're looking at it per sort of a single unit of time. And so our formula would be looking at that change in the outputs, and that change in the outputs is just like what we were doing in the last lesson, where we took that new value and we subtracted the old value. And then we're going to divide it by the change in the inputs. That's what gets us the single unit of time. Now, as I mentioned before, this is the same thing as slope. And so I put in here the slope formula because that might be a little more familiar to you. And so you'll notice that sort of right here, this is our sort of traditional slope formula. And it's just another way to describe the same thing we're finding. So we're going to look at two examples in which we find and work with that sort of absolute rate of change. So here we're just going to blanket practice finding it. We have 2 points, 4, -2, and 5, 3, and we want to find sort of the rate of change between the two. Now, outputs are on top, so we're going to do the absolute rate of change. So the outputs go on top. Well, the outputs, if we remember from the previous video, are the second coordinate points. And so we're going to have 3 minus -2. And it really doesn't matter which point you make the new value or the old value in this sort of abstract case. You just want to be consistent, okay? And then the inputs. And since I pulled 3 as my new value, 5 is going to be the one I pull first, -4. And then I subtract. So 3 minus a -2 would be 5 because I'm adding. And then 5 minus 4 would be 1. And so we have an average rate of change of 5 units per unit. All right. Now, let's look at this within a context. So we have a gas station owner who finds that for every penny increase in the price of gas, she sells 250 fewer gallons of gas. So if you're thinking about that in terms of a rate of change, it's important to think about the inputs and the outputs. So the inputs is what sort of you're setting the increase of. So it's every penny increase in that price of gas. So our input here is actually the price of gas. And if you notice, it says for every penny increase. So, you could decide to change it into dollars, or you can say, we're going to measure this in cents. So, 1 cent. And then the output is that then number of gallons sold each week. Because basically what we found, you could think of it as, for every 120 gallons, less, for every 1 cent increase. So it's like, that would be sort of our rate. So how much more or less gas would she sell if she raises her price by 10 cents? So what you could think of it as, there's a few different ways we could approach this problem. So, she's going to sell, so it's like if she raises the price 1 cent, then she's going to sell 120 less. And so this would be one time. So if she sells, then, she raises it another cent. So now she's risen it for a total of 2 cents. She's going to sell another 120 less. And so we could sort of keep, you know, going this pattern 10 times, or, and then, you know, sort of add up the total number of gallons. Or I could think of it as, for each cent, you know, she sells 120 less gallons, and we would have that 10 times here, right? Because this is, you know, 10-cent increase. So we're going to have that rate of change 10 times. So a negative 120 times 10 would be negative 1,200 gallons of gas. So she would sell 1,200 less gallons of gas if she rose her price by 10 cents per gallon. Now, looking at the next problem, how much more or less gas if she actually lowered her price by 5 cents per gallon? So this time, you know, if I was sort of thinking about that table method, you know, she's dropping the price a cent, which means she'd sell an additional 120 gallons, you know, because we're going backwards, you know, and so I could keep going, and I would do this 5 times because she has, you know, 5 cents. Or I could think of it as, you know, yes, my rate's that negative 120, but we're decreasing it by 5 instead of increasing it by 5. So we end up sort of with a positive value here, and it would be 600 gallons. So she would sell 600 additional gallons. So an advantage of lowering the price, additional. So those are 2 examples of how we can sort of find that absolute rate of change and then use it within the context. In the next video, we'll actually build some functions with the rate of change.